Good morning. Today we are going to discuss about fiber reinforced concrete. Usually plain concrete possesses a very low tensile strength, limited ductility and little resistance to cracking. This is all due to the presence of internal micro cracks within them. Because of that micro cracks, that plain concrete possesses a very low tensile strength. And in order to increase the tensile strength, many attempts have been made in the past, such that using reinforcing bars in the concrete so that the tensile strength of the concrete can be increased. But anyway, still then we were not able to achieve the inherent increased tensile property of the concrete. So in order to improve the inherent tensile property of the concrete, researchers have made attempts by adding fibers to the concrete so that the inherent tensile property of the concrete can be increased. And the reason for the low tensile strength in plain concrete is mainly due to the presence of internal micro cracks, and these internal micro cracks will be present in the concrete even before any load is being applied to the concrete member. And because of this because of this property, during the loading, the internal micro cracks will propagate and join together, just developing a failure material. And due to the researchers' effort, they came up with the fibers such that if the fibers are being closely packed in the concrete, that micro crack propagation can be arrested by those fibers. And that's why the name fiber reinforced concrete came into existence. It can also be called as fibrous concrete. And this fiber reinforced concrete can be defined as a composite material consisting of cement, fine aggregate, coarse aggregate and the fibers together. And this fiber reinforced concrete is defined as a composite consisting of cement, fine aggregate, coarse aggregate and uniformly dispersed continuous fibers. Next we will see about the fibers used to make this fiber reinforced concrete. The commonly used fibers are steel fibers, polypropylene fibers, nylon, asbestos, coir, glass and carbon. These are the commonly used fibers for this fiber reinforced concrete. The fibers can be of circular or flat. The fibers which are used in concrete can be of circular or flat in nature. Generally, steel fibers are mostly used in concrete and are of rounded type, and its diameter may vary from 0.25 to 0.75 mm. Next, about the volume of fibers. How much volume of fibers I should use in a fiber reinforced concrete? that is determined by the parameter volume of fibers. If my volume of fibers increases, then it apparently increases the tensile property of concrete, but the higher percentage of usage of fibers will also lead to harshness of the mix and segregation of the mix. Then aspect ratio of fibers. This aspect ratio is another important property which determines and influences the properties of fiber reinforced concrete. This aspect ratio is nothing but ratio of length to diameter. The aspect ratio of fibers is nothing but the ratio of the length of the fibers to the diameter of the fibers which we are using in concrete. Based on this, it has a certain influence on the properties of fiber reinforced concrete. We can use the aspect ratio fibers having an aspect ratio up to 75. Beyond 75, reports have been, beyond 75 it has been reported that it decreases the tensile property of the concrete. Up to 75 aspect ratio, we can use the fibers in concrete and it increases the tensile strength, but beyond 75 it leads to decrease in the tensile strength of concrete. Next about the orientation of fibers. How we are placing the fibers in concrete, that is defined by the term orientation. Either we are placing it parallel to the load application or perpendicular to the load application, or randomly we are distributing the fibers in concrete, and this orientation also plays a major role on the tensile property of concrete. And it has been reported that the fibers which were aligned parallel to the load application offered more tensile resistance when compared to that of the perpendicularly placed fibers and randomly placed fibers. Next we will discuss about the workability and compaction of concrete. This incorporation of steel fibers will normally decrease the workability, and if workability is decreased, then it leads to the poor compaction of concrete. So when fibers is being introduced to the mix, then it obviously reduces the workability of the fresh mix. So to overcome this, we can either increase the water cement ratio, or we can use water reducing admixtures. By doing so, we can increase the workability of the fiber reinforced concrete. And application where this fiber reinforced concrete are used. Let's discuss about that. Because of its increased impact and toughness and tensile strength, it's being used in overlays of airfields, road pavement, bridge decks, industrial flooring, etc. And this fiber reinforced concrete can also be this fiber reinforced concrete is also being used in the production of precast products like pipes, boats, wall panels, etc. Now we are going to discuss about polymer concrete. In the last lectures, we discussed that concrete is porous in nature, and many researchers have been working to decrease the porosity nature of the concrete so that the strength property of the concrete can be increased. And this porous nature is mainly due to the presence of air voids, water, voids, or inherent porosity of gel structure. And this polymer concrete mainly evolved to reduce this porosity, that is by combining concrete and polymer. Researchers worked to reduce this porosity nature of concrete, and the presence of air voids, water voids, and the inherent porosity of the gel structure is being reduced using techniques like vibration, pressure application, spinning, etc. But still then we couldn't able to achieve 100% porosity free concrete structures because of the inherent porosity of the gel structure, which is estimated to be about 28%. This 28% of voids is mainly because of the inherent porosity of the gel structure, which possesses itself before any load is being given to the structure. If we reduce the 28% porosity, then we will be able to achieve a concrete of higher strength. Here this polymer concrete is a composite made by combining the concrete and the modern polymer techniques. That's why the name polymer concrete. Now we will discuss about the types. First one, polymer impregnated concrete. Second one is polymer cement concrete. Polymer concrete. Partially impregnated concrete. This polymer impregnated concrete is being widely used, and here what they are doing is, first we are removing the air, any air voids present in the cube or the concrete member. This polymer impregnated concrete is a widely used composite material. Here what they are doing is, first the precast conventional concrete is dried in an oven or by dielectrical heating, through which the air voids is being removed by vacuum. Then low viscosity monomer is being diffused through the precast members, and subsequent polymerization is being done either by a radiation method or by heating. The types of monomers used for this polymer impregnated concrete is methyl methacrylate, styrene, T-butyl styrene, etc. Next, polymer cement concrete. This polymer cement concrete is made by mixing cement aggregate, water and monomer, and then the concrete is being placed in molds and subsequent polymerization is being carried out. The monomers used for this polymer cement concrete are polyester styrene, epoxy styrene, furans, etc. However, in this polymer cement concrete, we couldn't able to achieve a concrete of higher strength compared to that of the conventional concrete, and this may be because of the incompatibility between the monomer and the conventional concrete, and the reason behind this may be due to the incompatibility between the aqueous solution and the monomer being used. Because of that, we couldn't achieve concrete of higher strength compared to that of a conventional concrete. Next, polymer concrete. It is a concrete made by aggregate bound with monomer. This polymer concrete is made by binding the aggregate with polymer instead of Portland cement as in the conventional mix. Here our main aim is to reduce the voids. So what they are doing is, they are grading the aggregates such that the aggregates are packed to a higher density with minimal voids. After that, the monomer is being injected into the molds containing this highly graded aggregates with minimal voids, and after injecting the monomer, the subsequent polymerization is being initiated, and that concrete is called as polymer concrete. In partially impregnated concrete, this partially impregnated concrete may be used in situations where the concrete is subjected to wear and tear, that is, that property alone should be resisted by this polymer concrete. The surface where the surface is being subjected to any mechanical or chemical action, abrasion action, etc., there we can use this partially impregnated concrete. But even though the partially impregnated concrete show good strength when compared to that of the conventional concrete, this polymer impregnated concrete can be produced by initially soaking the specimen in a monomer, then sealing the specimen under hot water at 70 degrees Celsius to prevent any loss due to evaporation. The depth of monomer penetration depends upon the following factors. First is pore structure of hardened and dried concrete. Second is the duration of soaking, and third is the viscosity of the monomer. Based on these factors, the surface resistant properties of the concrete can be improved. Its applications are: the applications of polymer concrete has been found useful. The application of polymer concrete has been found useful in numerous applications as follows. First one, in prefabricated elements, then in pre-stressed concrete, marine works, nuclear power plants, sewage works, that is in form of pipes, and disposal works, waterproofing, etc.